Hello, geometry, and this is our first official lesson. We are going to be talking about naming. I cannot tell you how important this is for all of geometry, all right? So make sure you're understanding and taking good notes. It can be a little confusing the way that we talk about things, but this is critical for the whole rest of the year, and you can always go back and refer to this video. So let's start with a point, all right? A point is a dot. That's right, it's a dot. It has no dimensions, nor distance. We always use a capital letter. So in our little picture right here, I would call this point A. Always use a capital letter when referring to a point. Now, let's talk about a line. All right, a line is made up of infinite points. All right, a line is made up of infinite points. Any 2 points form a line. So a line has no width and it has no end. All right, so here we've got point X and point Y, and they are forming line N. We name a line by any 2 points on the line or a lowercase letter. That is very important. So we could call this line N. I try to make it kind of italicized so it looks a little different. Or we could call this line XY. Make sure you have the appropriate hat. We're going to get into that more soon, but you want double arrows, all right? Or we could call this YX because those are points on the line. It does not matter which of those, when I tell you line XY, line YX, or line N, it's all the same line according to our picture here. So collinear points are points that are on the same line, and non-collinear points are points that do not lie on the same line. So far, so good? I hope so. Line segments. A line segment is part of the line defined by its length. All right, so in this case, we have point G and point H. So this would be segment GH, and it's got no arrows. Okay, the hat has no arrows. Or we could call this segment HG. Again, no arrows. Line segments have no arrows. Lines have arrows on both sides. That's why hats are so important. That way we know what we're talking about. So rays, just to make things a little more complicated. A ray is a part of a line. All right, it's part of a line. It starts at an end point and extends forever in one direction. Not like the band. All right, it extends forever in one direction. So for example, we have line K here. We could have ray EF, and I'm going to do the arrow towards the F. So it'd be like this, right? EF, where it continues forever in that direction. Or we could have ED. So its endpoint is at E, and it goes forever in the direction of D. We could have FD. So it's the endpoint's at F, and it goes forever in the direction of D. We could even have DF. And these are all different rays. None of them are the same. They're all different. So the last one starts at D and goes in the direction of F forever. Opposite rays are important. 2 rays that start at the same endpoint but extend in opposite directions. All right. If you think about it, it's basically that they form a line. All right. They form a line. So opposite rays form a line. In this case, when we look at this example here, opposite rays would be EF and ED. All right. EF and ED are opposite. They both start at E. One goes towards F. One goes towards D. DE and ED would not be opposites. They don't have the same endpoint, all right? So we've talked about points. Points make up lines. Now let's talk about planes. Not like airplanes, though. So a plane is a flat surface. All right, a plane is a flat surface. Think of it like a piece of paper or a tabletop. It's a flat surface. Any 3 points make up a plane. If you ever have a wobbly stool, I know sometimes this happens in science classes, you'll sit there and the stool will wobble. It wobbles because it has more than 3 legs. If you only have 3 legs, it will never wobble. It might not be comfortable, but it will not wobble. So any 3 points make up a plane. So in our little picture here, we have point K, point J, and point L. They make up plane P. 3 points make a plane, and it works great. A plane extends infinitely in all directions. So even though I have this kind of parallelogram drawn, that's just to help us with a visual of it. It keeps going forever and ever and ever and ever and ever. All right? It never stops. We name a plane by any 3 non-collinear points. Non-collinear. They cannot all be in the same line, all right? 3 non-collinear points. Or an uppercase script. So we would call this plane P, or we could call it plane JKL, or we could call it plane LJK. The order of the letters does not matter. All right, the order of the letters does not matter. We just want to make sure that we're using 3 non-collinear. So none of these all lie on a line. We want them not to all be on one line. All right. That is how we name things. We're going to continue this with some intersections and some more terminology in our next video.